Hi, my name is Randy Garrett. I'm the product manager for the PCI Express Gen 5 Protocol Analyzer and Exerciser. And today I'm going to walk you through a little bit about the hardware, and then we'll do a short demo around the software so you can kind of see how the interface looks. So first I'm going to start out, I have the PCI Express Gen 5 Exerciser. You'll notice it's full height, half length. It plugs directly into a CAM connector into the motherboard. We have 3 different versions of the Exerciser available. There's the by 16 that'll fit into a by 16 connector. Then I have a physical by 8 and a by 4. So if they're using smaller connectors on their system, we have Exerciser and Analyzer cards that will plug into both of those. Next, you'll take a look at the PCI Express Gen 5 Analyzer, and you'll notice it's all self-contained within the CAM card itself. So there's no longer any cables that go out to an analyzer box. It's all self-contained. The memory, the analyzer, all of that is within this CAM card. You'll notice it's about a double height card, but it's still half length. Then here on top is what I'm going to be communicating to and talking to is this PCI Express SSD. And so I'm using the Exerciser itself as the root complex, and it's going out and talking to the add-in card, the SSD. The Exerciser can be used either to emulate a root complex or an endpoint, and could be used either way. So if I was plugged directly into a customer's motherboard, I could put the Exerciser on top of the analyzer and act as an endpoint, and I could communicate and see the traffic flow between the CPU and the Exerciser acting as an endpoint. So it can be set up a couple different ways. Right now I'm going to emulate the root complex, and I'm going to talk to this SSD. With that, I'm going to kind of transition into letting you take a look at the software, how it's set up, and walk you through a quick capture. The interface will normally come up with a module setup window like this, and I've already selected them. It goes out and queries that you have a license set up on your PC, and then it queries the hardware. And so that takes just about a minute to set up. I've already set those up and it's running. You notice there's an online mode and an offline mode. So if you don't have an analyzer and an exerciser, you can still download the software and use it in offline mode to get familiar with the interface and understand kind of how to maneuver through the interface and how to view the data. You'll notice right here at the top that the exerciser and analyzer both show up as tabs. And so right now I'm in the analyzer menu, but I can quickly jump back and forth between the exerciser and the analyzer. And that gives me a chance to make it real simple to set up both of the products and execute so that I can start a capture, and I can also stimulate the bus with reads and writes with the exerciser. So right now I'm in the exerciser menu. You click these little arrows over here and it'll bring up your navigation bar. Also along the top, there are the same icons that can be used to jump to those navigations. So it's very quick navigation. And if you hover over it, a flyout comes out to tell you what that, where that will take you in the setup menu. If you go over here to the right side and you pull up the hardware status, this is a really important window because it tells me whether my link is active and what speed it is and what width it is. So, so right now the DUT that I'm using is an SSD, and it's just a by 4 width. And so I'm going to go in and set that up. This is the menu looking at the exerciser itself. So the exerciser, since it's acting as the CPU, it's looking downstream to the DUT. So that's what I've got the session type set up as. If I was acting as an endpoint or as a PCI plugin card, I would be looking upstream towards the CPU, but I'm looking downstream for this demo. The supported link widths. So even though I have a physical by 16 connector on the bottom, I have link widths. I can set the link widths from by 16 all the way down to by 1. Right now, I'm just going to say that my exerciser is going to communicate to the DUT that it's a by 16th width, and the DUT will communicate back that it's a by 4, and so they'll link up at a by 4 speed. I mean a by 4 width. So the data rate capability, since it's Gen 5, it goes up to 32 gigatransfers per second. And so the exerciser at this point is basically set up to do link training and go in and start communicating with the DUT. So I'm going to go up here at the top and I'm going to start the link training. And you'll notice over here, it went from no link and now it says active. It's in a by 4 width and its speed is at Gen 4. Unfortunately, the DUT that I have right now only goes up to Gen 4. So I don't have a Gen 5 DUT to plug in at the moment. But you can see it went up to max speed. You can see the advertised data rates. Like I said, this is a very important window because it tells me when my link is active or when it's not. So if I have some issues, I go look at this screen and make sure that I can see whether my link is active or not. Now I'm just going to bounce over to the Analyzer menu and set it up. So I have the setup menu right here. This is going to let me go in and say capture length width. I'm just going to go in auto mode. Otherwise, you can click right here and you can select specifically what link widths you want to capture. But I'm just going to let it auto detect because the exerciser will go out with it's a by 16. The DUT will come back with it's a by 4 and it'll set itself up as a by 4. Okay, I'm going to apply those settings. Then I'm going to go over to the capture window. So this is my analyzer. I can select my memory depth. We have up to 16 gigabytes of memory depth. But I'm just going to take a smaller trace. That way it's a little quicker and easier to process the data. Everything else is set up. I'm just going to auto detect the link speed. So I'm going to hit apply and OK. And now my analyzer is set up for that. So now I'm going to go over to my trigger menu and I'm going to bring it up. So now I have a large number of trigger options available, from very simple triggers to very complex. And as all you do is you go down here, I'm gonna set myself up to look at a config read type 0. I already set that in there, but if I want to, I can click it and remove it. And then I can come down and find the trigger sequence that I want. I'm going to go back to this config read type 0. And then you just drag it over and drop it. Now I do have multi-level triggering, so if I want to add additional if-then-else type triggers, I can just keep dragging them into the trigger window. But right now I'm just going to trigger on a config read type 0. So I'm going to hit apply. And up here you can also set the trigger position. Right now I'm just going to trigger in the middle of the trace, so there'll be some amount of data capture before and then 50% after also. Okay, I'm going to hit OK. I'm going to run the analyzer, and you'll notice down here in the bottom right-hand corner, it'll come up with a status, and it says waiting for PCI for trigger. So we know that the analyzer is running, and it's waiting for its trigger, and it's looking for a config read 0. So I'm going to bounce back to the exerciser now. What I'm going to do is I'm going to go out and read from the config space of the DUT. So if you come down here, you have a DUT config space. There's also a config space of the exerciser itself, which quite often confuses me. So, but you can look at the config space for both, but it really is what I want to do is I want to read the config space for the DUT. So I'm going to come down to that. You'll notice it has a device, the bus number and device number and things. I'm just going to go out and scan the config space, and it'll bring back the information from the DUT of what the config space looks like. It takes a second to come up. Then it gives me a whole bunch of tabs on ways to view that. So all the information is contained here kind of in a list. I like to go to this view just because I'm used to it. And it tells me the device ID, the vendor ID, which it's a Samsung SSD. And then it gives you all the information on the different registers that are stored within the config. So that should have sent out a config read from the exerciser to the DUT, and that would have triggered my analyzer. So if I bounce back over to the analyzer, you'll notice it did trigger. It triggered on this config read 0, which is exactly what we wanted it to. I'm going to take a look at, you can see all the different transactions that are going on. So it sends out a request for the config read 0, gets an acknowledgement back, and then a completion happens with some acknowledgements. So if I go into the transaction decode and I hit this button compute, it'll take, I think we're running 32 megabytes of memory, so it'll take 5 to 10 seconds for it to compute. But then you can see the transactions and it groups those together. So instead of being a split transaction where it makes a request, gets an acknowledgement, and then gets the completion and the acknowledgement that it completed. It puts all of that information into a single transaction, so you can quickly see, here was my config write, type 0, and my config read. And so you can quickly see what happened on the bus, and it just compacts those transactions together. There's other views down here in the menu that you can look at. So you could also look at details of one of the packets, look at the header information and see all the data within it. Like I said, that was just a simple walkthrough of the interface, how to use the exerciser and analyzer together, and how to set it up to capture a trace on a config read. Thank you.